Hi guys, today I'll be talking about metric space. But before I give you the definition of a metric space, I would love to define a metric. So, simply put, a metric is a distance function. A function given the distance between any two elements of a set. So, we have to define it on a set. So we say that let S be an arbitrary non-empty set, and then we define a metric, which I already told you is a distance function, on S as a function which you can denote with any symbol of your choice, but let's choose D. So it is defined on S cross S, the Cartesian product of X, and the output of this function is in the set of real number. I already told you is given the distance between any two elements of the set, satisfying the following conditions. So the first condition is the non-negativity condition, which says the distance between two elements is greater than or equal to 0. So d of s comma y is greater than or equal to 0 for every x and y in X. So, and d of s comma y is equal to 0 if and only if s is equal to y. So this is saying that the distance between any point of the set S, it will always be greater or equal to 0. The distance cannot be negative, right? So, and then the only reason why the distance between the two elements will be 0 is if those two elements are equal. Like, what's the distance between 2 and 2 in the set of real number? It's always 0. It will be 0. So we say S is equals to Y. And then the second condition is the symmetry. So we are saying that the distance from S to Y is the same as the distance from Y to X. So that's the symmetric condition, and then we have the triangle inequality. So it says that d of s comma z is less than or equals to d of s comma y plus d of y comma z. So you can simply say that the distance between x and z is less than or equal to the sum of distance between x and y and the distance between y and z. So as you can see in this diagram here, in this triangle, so if you decide to pass through this xyz, so you already seen that adding the distance between x and y and the distance between y and z is always greater than or equal to the distance between x and z. So that is a metric. Any function satisfying these three conditions is regarded as a metric. So what is now a metric space? So a metric space, we write it as this. It is a pair, which is a pair of the sets and the metric, the distance function. So formally you can say a metric space S comma D is a set S equipped with a metric D. So the pair S comma D is what is called a metric space.